The UCD Intel Masters Scholars is a program that rewards creativity and innovation, something that this global pandemic is asking a little bit of us all as we adapt to the new normal. So we turned a live event into an online series. It's called Message in a Bottle. Enjoy.
Hey, my name is Ciaran O'Sullivan and I'm in my 5th year of Chemical and Bioprocess Engineering in UCD, just finishing up my Masters this semester. This is a quick run through of my experiences with engineering to date. So I suppose when I was younger I always was quite into problem solving and maths in school. When it came to the Leaving Cert, I decided to pick biology, chemistry and physics, so all the science subjects. I think I kind of knew at that stage that I really wanted some sort of career in science or engineering. I had a particular interest in chemistry. I just thought it was a bit mad or cool that all matter was made up of these tiny molecules that could be manipulated or reacted together to create new or kind of generate different, more desirable substances. So I applied to UCD engineering and managed to secure a place off the back of my Leaving Cert results. And straight away in first year, I found it really interesting solving problems across a wide range of modules for the different engineering disciplines. But I was particularly interested in the chemical engineering option module called Process Principles. And it gave me a good chance to see that chemical engineering would allow me to continue to explore my interest in reactions and chemistry, along with the added elements of process engineering, problem solving in chemical engineering. So that was one of the main reasons why I decided to choose chemical engineering as my desired stream from second year onwards. So then in second year, we were put to work straight away. It was really good to start learning and develop the basics, the fundamentals in chemical engineering, and I got a good kick out of solving problems and completing assignments and doing project work. And I thought it was interesting that right away we were being tasked with applying theory and knowledge we were learning to develop processes and complete project work. One project in particular that we did in second year, again with pretty basic knowledge of chemical engineering, was to design a basic heart and lung machine based on heat transfer and fluid dynamics theory that we learned. And a heart and lung machine essentially takes over the function of heart and lungs, the heart and lungs in surgeries where possibly there's a bypass being done or a transplant of some sort. So I thought it was really cool that straight away we were developing skills to design these kind of machines and equipment. In third year, and I was really lucky to get the opportunity to study abroad for the year at UCSB, which is the University of California, Santa Barbara, which is a couple of hours north of LA. That was a really interesting experience, really fun year. It was a pretty competitive class, highly ranked or highly high achieving students that were all competing to secure spots in graduate schools and go on to do PhDs in some of the best schools in America and across the world. So it was really interesting to mingle with them, and it was interesting to see as well that the stuff that I'd done in UCD in second year gave me transferable skills that with a bit of elbow grease I was well able to keep up with the class. But aside from that, I had a really good time traveling. I got to travel loads of America where I'd never been before, and got to see plenty of California and other places like the Grand Canyon and Zion National Park, and particularly stick out in my mind. And then also obviously I got to make loads of new friends and develop some engineering connections with other classmates and lecturers who I might hopefully cross paths with again in the future. Over fourth and fifth year I've become quite interested in the pharmaceutical side of chemical engineering, given there's such a big the pharmaceutical companies have such a big presence here in Ireland. So I did some really interesting modules led by NIBRT, the National Institute for Bioprocess Research Training. One, for example, was on facility design and operation, and kind of gave me a good overview of what exactly goes into designing and operating really stringent pharmaceutical facilities where they're designed and built to really high specs to make sure products are safely manufactured for patient use. And again, it gave me a good idea that chemical engineers are involved right from the outset in the design and operation of these kind of plants because of their problem solving skills and their knowledge of the science behind the chemical reactions that are used to develop the drugs, as well as the process principles to get from your starting materials to your end product. As part of my master's, I did a year-long master's placement in Bristol Myers Squibb, the manufacturing facility that they have here in Dublin. BMS are a big pharmaceutical company based in America, and it was a really interesting experience working at their site for the year, which was actually in startup when I was there, so it was really fast paced and I got to learn a lot about how a pharmaceutical facility is run. And I learned a lot from a really talented team of scientists and engineers that I worked with. I ended up doing my master's project on site in Cruiserath with BMS, and it focused on feeding strategies in the production bioreactor in a pharmaceutical facility. So optimizing the manner in which the cells, which are the workhorses or the powerhouses of biopharmaceutical processes, optimizing how they're fed to maximize the drug substance output that they generate in the production bioreactor. That was a really interesting project, and it kind of gave me a good idea or a good opportunity to explore some of the more scientific design of experiments and research methods theory that we learned in our fourth year of the chemical engineering program. So that's, I suppose, a quick run through of my experience in engineering so far. I'm hoping now to, once I finish my studies, go into industry and find ways that I can increase efficiencies in processes that I might end up working on, or optimize particular parts or pieces of equipment, so that I can make a real difference. And I think that's one of the great things about engineering engineers and scientists possess the skills to solve problems needed to make a real difference in the world and kind of increase our standard of living and our knowledge of the world in general. Thanks.